Login accepted.
Yeah, that's me. First of all, thank you guys. I'm really grateful to be here. The fact that we all can be here in one place, talk to each other, talk to different companies, is absolutely great, right? After 2 years of COVID, being at home, working remotely, this is an awesome opportunity. But at the same time, it feels a little bit weird because all the screensaver is all like people hacking, there's access granted, the guy in the hoodies, and I'm standing here on the stage representing a bank or financial institution, right? So it feels a little bit weird. But we're going to talk about things that are applicable in any company, not just financial institution, but any technical company, right? So this is what we're going to talk about. We're going to talk about a little bit of theory, stability, reliability, some best practices, then we're going to switch to code. Hopefully things work. And then I was actually hoping to get some Q&A, but I don't know how it works with the mic. I can't really see you guys. So what we're going to do, if you have questions, and I hope you do, we have a booth outside, BNY Mellon, and stop by, and I'm going to be there, and a bunch of my colleagues as well. We can talk about stuff, technology, not necessarily finance, right? So it's a sponsored chat, so I have to talk about my company, our company. And I'm going to bore you with those numbers because trillions, billions don't really, this is in dollars, so we're talking a billion, a lot of money. But the point is that we are, and not many people know this, we are a financial institution. We work with different banks. We work with banks across the world. We move a lot of cash. We spend $3 billion in technology alone every year, right? But that's a question. So we are, you can think of us as a technology company, right? There is no finance right now without technology, right? A lot of different projects, a lot of different technologies, but big presence in Wrocław. Apparently, I'm talking to people that nobody knows us outside of Wrocław, so that's why we're here. But I'm here as a technologist, not as a financial person. And a side note, believe it or not, people have different perception of financial institutions, especially like investment banks, like people in suits, working with suitcases, this type of thing. This is the first time I'm wearing this shirt because I just don't wear shirts. I have, my suits are gone. So it's the first time usually t-shirt, hoodie. We have remote policy, work from home, but it's still technology, right? So here we are in Poland, building technology organization, lots of different things, numbers, crunching numbers related, right? So that's about us, right? Still banking, still technology, right? Now, let's talk about microservices, right? I'm not sure which chats you guys or which sessions you attended, so I'm not going to bore you with definition. What is a microservices? How they work? What is the software to use? I mean, there's just a ton of different definition, different setups, right? But what's interesting here, if you look at this, and again, as a technologist in a financial institution, I did not come up with this definition. I took it. I took it from Amazon, right? So there you go, there's a credit. And that's what we do. We use Stack Overflow, we use other services, we use technologies for a better service, for better good, right? But this definition is quite interesting if you look at it, right? It's not only about technology. It's not about only writing microservices in whatever framework you choose, but it's also about organizational approach, right? So if you think you have a group of 100 people that work on a single project, if you think you're going to have a successful microservice deployment of some big system, you have to think again, right? You really have to start with the organization, the right organization to have microservices, right? I don't know, one pod, one team, 5, 6 people. We heard a chat about the 2 pie type of concept, 2 pizzas per team type of thing, right? So there are different approaches, different organizations, but they have to go together. They have to go together, and here's what we also do. We know we try to practice this. We have small teams, 5, 6 people, cross-functional, so we have UI, backend. They work with business, but we try to adhere to these principles that came from Amazon, right? They're still kind of the leading provider of cloud and other services. Really a lot of good, interesting articles on that site. Go in your spare time, Look it up. You can learn a lot, right? That's another thing, right? You have to keep learning, right? So 3 main categories, just to summarize, 3 main categories that what makes microservice, they have to be autonomous, right? Like if you're deploying in your company, if you're deploying your microservices together at the same time, and that's your requirement, it's no longer microservices, right? Like so they have to kind of work independently. You have APIs, you have REST point, you have definition, things like that, but they have to be autonomous, right? Specialized, right? Specialized in the sense that you should be clear what each microservice does, right? Like, and this is a problem where, we all live in this great resignation or period where folks looking for different opportunities, different challenges, and if somebody joins and they look at your project or set of projects and there's like, what does this microservice do? How it works? And they can't figure this out, or they need some other senior developer to tell them what it is, how it's structured, you're not going to be successful, right? So trying to get to a point where it's specialized, they know what it does, it's restricted to specific functionality, right? And finally, scalable and resilience, right? Like that's for us, this is a big thing. We cannot afford to be down. We cannot afford to tell another bank, right? Like, sorry, you can't send us transactions because we're right now restarting or rebooting or whatever, right? So they have to be scalable, and that things happening in the market, and this is what makes things, working in companies like ours, like exciting because there's always something going on, right? I don't know how many of you follow what's going on, but for example, last week we had interesting things going on with crypto space, right? We had 2 weeks ago, market was kind of bouncing up and down, right? So always something interesting, and then the volumes, you can't predict the volume, so we have to make sure that it's scalable and resilient, right? So that's the general definition, right? High level. So let's talk about stable versus reliable, right? And some folks, you might think that they are the same kind of similar definitions, right? Like their stability, reliability, it's the same thing. It's actually, there's a slight difference, right? If you look at the first definition, right? It's the stability is characterized by sensitivity to change of a given system, right? And things change. In financial markets, things change all the time, right? Like there's new regulatory requirement, the client has different requirements, so they change. So you have to be able to quickly adjust. But when you start changing code, like things might break. And nobody I guess on your left, on my left, whatever, on this side of the screen, right? You see what is stability, right? You have this code when it's 0, when you have mod 10, mod 0, you have a different type of printout that you would expect versus what you get in any other condition, but it doesn't happen all the time. Now, obviously, nobody would ask you to write code like this. But when you're dealing with 10, 20, 50,000 lines of code, and you have, formulas, parameters all over the place, most likely something like that would happen, right? And that affects your stability, right? Now, reliability is something completely different. When a specific condition happens, things blow up. And again, who would write the throw exception? Who would write? And again, this is just pseudocode, so nobody writes code like this where you purposely throw an exception, thinking that it's going to get caught in some higher tier, right? And the tier gets changed, and then all of a sudden the client is looking at a nice stack, exception stack. Hopefully that you have printing of stack exception, or you coded the fact that they get a nice message format message and only developers see the exceptions. But it's also possible, right? So reliability is another thing, right? Again, you can risk, and it's all about managing risk, right? Like for us specifically, for vendor software, they have to make sure their software work. For us, it's about managing risk, right? You have to have, it's not always perfect. You have to manage it, but you manage the risk, right? So we're going to talk about the different things about this stability and reliability and how you can control it, right, in software development. And again, it's not applicable only to finance, it's applicable anywhere. All right. So let's talk about it, right? Let's talk about stability, right? So first, stability, right? Changes in the code. When you're writing code, things that you worked yesterday, or let's say on Friday, you had a deployment on Saturday, all of a sudden Monday things don't work. That's usually the stability problem, right? And what can you do, some of the practices, some of the things that you can do to not avoid it completely, because that's not possible. Let's be realistic, right? Like, but at least reduce it. And this is the thing, right? A lot of things I hear that, oh no, it's time, we need to deliver this. It will bite you. It will bite you back, and you have to invest time before you go your first release, but then you continuously tackle the technical debt, right? So let's start with development practices, right? Clean code, right? You guys heard about, I think, 2 other speakers that were before me. They were talking about clean code. There's so many different definitions of clean code, what it is, how it should work, but for me specifically is about ability to read what somebody else wrote, right? The situation that I deal with, and again, I'm a developer, right? So I still write code. I'm also managing a team, and we also manage a fairly big system within the bank. So people come and go. I have to code something. I code everybody. There's no one place where, so everybody is kind of like an open source. Everybody touches everything. So we look at different code. And if I can open up a class or a set of functionality starting with the REST controller all the way to service and some logic, and I cannot figure out what's going on. I have to turn on the debugger, get some data. It takes me a day to just set up to understand what's going on in this code. That's not clean code, right? And again, there's thousands of definitions, different principles, but in reality, it boils down to the fact that you open something up and you can read it, right? So it's not easy to get to that stage, and you know, it takes maintenance as well, but it's really required to avoid stability. Automated testing, believe it or not, and I keep hearing the same thing. We have to deliver by a certain date. We actually made it a requirement. I made it in our project where you can set up, and we use actually Maven. So we have a Maven plugin where we check coverage of the code. So if a developer is in a rush, for example, and doesn't add the test, corresponding JUnit test, then the build will fail, and he'll get a nice email saying, hey, you broke the build. It's not the end of the world, and this is the culture that we're trying to install. It's important that folks, not only developers, and we should make it mandatory for managers and owners of companies to attend conferences like this. It's nothing wrong with breaking a build, but the person should really fix it because it's preventing somebody else to proceeding, right? So automating testing is critical in that regards. Again, I'm not going to go into the frameworks that we can use. Happy to talk to you guys outside. Again, ton of not a lot going on in that space, but there's different, you know, integration, JUnit tests, integration tests. You know, you have a lot of different things going on there. And quality, right? Measuring quality. You can't really measure quality if you do code reviews, right? Like how many really, you do a code review, it's very could be subjective, right? There has to be some basic measurement that you can check. Things like SonarQube can check for you. It's like, hey, you know, maybe this parameter is not being used. Why do you have it, right? So there are things that you can do that require some initial setup, but then can really pay benefits and do not require another person actually saying, okay, you did this wrong, or something else, right? Automation, different vendors, different solutions, but again, you need to have developers who want to develop, right? That's the bottom line. That's what we are, right? Like, I don't want to spend hours, days deploying code and doing stuff, right? We need to automate this, and again, there's an initial investment that you have to pay, but depending what you use, it can be as simple as you know, one script running on your GitHub or GitLab, and then everything is just either click of a button or actions are done automatically. But one thing I've learned working with other developers that, yeah, folks don't want to spend time doing this type of thing manually, right? Like, we want to code, we want to learn, right? And environment is a big part, right? If environment is unstable, you're going to spend time investigating it, and it's not the code. You don't know if it's the code. First thing we think is like something else, right? So I think that the culture I try to instill is that, okay, first let's look at the code. If the issue is on Friday, if something is happening on Monday, pretty likely that we messed up. We as a team, and we need to look at the code, right? And not something that happened if it happens on Wednesday or some other change went in, then we look at that second, right? Find managing complexity. So managing complexity. So in this current environment, right, like where things change so quickly, and not only the market, not only the requirements that you get, but also people, right? People, projects, time, everything changes quickly, so you have to manage complexity, right? And the one way to do it is keep it as simple as possible, right? I had multiple occasions where a new developer shows up and it's like, okay, we have a requirement to do, and it's like, let's use framework X. Like there was a project where we had to move a file, do some basic validation of the file, and just send it somewhere else. One file a day, let's say, right? And we like brought this Spring integration framework with some Kafka, and there was something else. And it's like, it's great. And it's like when we sat down, it's like, why do we need this, right? It's like, I really want to learn this. It's like that's usually the reason. Like folks bring some framework, some. Yes, maybe it's a good framework, and they all bring the value, but like they bring it for the not necessarily the right reason. The reason is I want to learn it. So one of the policies that we have is, okay, you want to learn something? All right, take some time, Friday or whatever, and learn the practices. Don't bring it into the project until you really can make a strong case, not only to your manager, but to other team members, that actually it's going to add value long term, right? So managing complexity is very important. Anomaly detection is something that, yes, you can do in the code. Usually there are tools for that, so we're not gonna really talk a lot about that aspect, right, for managing stability. So reliability, right? First thing you have to ask yourself, what changed, right? And that's folks responsible for managing this aspect in big institutions or in support organizations. Like that's the first thing you should ask. What changed, right? And it's not always easy to determine what changed, right? Is it the environment? Is it the database? Is it the version of the library? Is it the code? You have to put this together as quickly as possible, right? Like so that's the first thing that, and then you can, once you know what changed, it should be very easy to either roll back or look at the changes and see if can they be contributing to this problem, right? And again, we're gonna look at that. We're gonna see how it's easy to determine. I'm gonna show you like a sample app that created, and we're gonna look at that, right? So the sooner you identify the problem, what changed, the sooner you can start fixing or looking at it, right? Environment issues. So sometimes, environment is not, and when I say environment, I'm talking about like infrastructure as well. Let's say, or whatever, Kafka broker or your database cluster or your caching cluster, right? So things can happen, your network, right? So things break all the time, and it doesn't mean necessarily that your application is going to start breaking right away, right? Like, okay, we know that caching went down, like, but the user didn't notice, let's say, in our organization. When you have hundreds of thousands of users, let's say Amazon, Google, like they cannot afford, somebody's out there shopping, right? Or looking for a dress, right? Like, but really, I mean, those are cases that we don't really deal with a lot. But like, if it's a small environment, and let's say your application is, maybe not used for half an hour, there's a possibility you can detect those changes, address the changes before it's even noticed, right? When there's a higher load, when your SQL query, so no SQL query, is actually taking longer to execute, and you have ability to detect that, and there are ways to do it, then your client might not even realize, right? And the problem that was avoided is one problem less problem to deal with, right? Also, from my experience in working in this environment, like data, a lot of times people don't realize it's not always software, right? It's not always code. It's data that is actually the problem, right? And we can't really use it as an excuse later on. It's like, but we never saw this case. We never saw a transaction with 9 zeros. Believe it or not, we had it last year. It's possible, right? But our system could only handle 8, right? So there are situations like that. It's data, so we have to be able to, first of all, possibly using the right controls, if we can get the sample data set from production, maybe copied it from production, maybe set up a process that does it real time or near real time, so that you can, in your development, in your test environment, you can deal with real scenarios, not only something that somebody put on paper, right? Because the person that's putting it on paper may also not know all the cases, right? So this area is very important, that when you're working with this type of problem and you start seeing that your reliability start decreasing, that you look at this, and maybe one of the areas that you look at is actually setting up the proper test data and automating that aspect. And we're going to see what are the signs of the trouble that's coming, right? That you can also detect those, right? And I also mentioned this is the kind of managing complexity. It affects both categories, so I put it here. But that's, you have to also, the less factors you have to consider, the better it's going to be. The easier that, I think one of my other presenters mentioned the 2 o'clock in the morning call, right? So you don't want to get that call. And nobody in 2 in the morning, especially after going out, can handle this, right? So you have to know the environment. You have to be able to tell somebody that, hey, look at this. They should have all the information that you need, or because it takes me, let's say, a couple minutes to log in, right? I need to jump in and take a quick cold shower. So that's complexity also affecting that, right? So I mentioned the kind of like early signs of things that you are kind of getting in trouble. Like, first of all, you have to be in production, right? You have to be working in production. You have to be working with real users and not just developing software for the sake of software, right? Again, there's a lot of things that we do as developer, proof of concepts, and again, great presentations on that. We're talking about systems that are actually in production, right? And you have to start thinking as soon as possible, not even like after it goes live, before it goes live. What can I add? And we're talking about literally maybe adding 3-4 lines of code that can make a difference when it goes live, right? So this is a great, again, I took this from Marcin Fowler, right? If you want to actually do more reading about this, the link at the bottom. There are certain, and again, I changed it a little bit because as it's applicable to financial industry, that some of the categories, right? So look at the problem that your software most likely is going to break when it goes to production, right? So here we're looking at top 9 categories, right? So I think, and Martin, this came from Marcin Fowler. So your unit test, right? So first thing, your unit test, provided that your application has unit tests. If you don't have unit tests, like, there's no chance. I mean, there's really no chance that you can reliably keep releasing that software to production, right? No matter what theory, no matter what arguments, we have no time to write. It's just, first release might be successful. You're sitting there and praying that let's hope it works. But if you do not have units, there's just no way to consistently release code, right? And again, what is your goal? Depending on the company, depending on the domain, you might have different goals, right? For example, in my area, my system, and it's, again, fairly large system. We deal with a lot of data coming from a lot of different vendors. We release weekly. We release to production weekly, right? So we rely on unit tests, and now your unit test really should run like 5 to 15 seconds. And again, guys, don't get stuck on these numbers. Like, this is my opinion of view, right? Like, and Marcin Fowler, I agree with him. He's the domain expert on this. There a lot of studies went into. So 5 seconds, more or less, you hit the test and you see all is green, right? And I keep telling the same thing. Is unit test. Somebody can write a unit test, and just because the coverage, somebody checks the coverage. I have one more test. But really, when you're writing the unit test, whatever framework, however you do it, write it in a way that you want to run it yourself, right? That's this key secret. I mean, there are rules of writing good tests. There's like 12 rules of writing good tests. There's a lot of things about writing clean tests, but it boils down to the fact that you want to write the test in a way that you want to run it yourself. When somebody else starts working with your code, right, that you wrote, that you're proud of, this test will capture when they make a mistake. Because they're not going to break your code intentionally. They're going to write something, maybe they're in a hurry, the test catches it, right? So, but if it runs too long, and for example, we use Spring Boot and Spring Boot framework, like if it takes longer to start up, folks will rush because it's just, we don't want to wait that long, right? So seems like 10 seconds is kind of like the sweet spot. Now, let's say we have a production error. User says, hey, this data doesn't line up. It's not per what we expect. And normally, if it takes you about a week to find what the root cause problem was, let's say 3 days ago, it's easy to find the problem now, usually, right? But if it was on Friday and they're only letting you know on Tuesday, let's say, or Monday, and it takes you about 4 days to find out what exactly happened, then that's another sign of trouble, right? Usually the rule said if you can within the same day let the user know that, hey, we had a bug, right? We had a bug, but we know what it is. Depending on severity of this bug, depending on the effect of this bug, they'll work with you, right? So it's so 1 day, I would say this is the kind of benchmark there. Integration testing with live data, tricky topic. That could be a session in itself. I think we had one session. I unfortunately didn't attend, so I don't know. But integration testing, setting up the right integration testing, setting when do you run integration tests, right? Do you run it with every build? Do you run it at night? Do you run it before the release? A lot of factors to consider, but you should have integration tests. And what a lot of folks do, let's say with Spring Boot, and I'm going to keep referring to that framework because that's what we use, they would set up fake data, and they would run integration tests with all the services, the REST controllers, etc., but it's still with fake data, right? So what I would recommend in that regards, try to use real data not from a database because that changes, but maybe offload it into a JSON file to some other storage that doesn't change. That's your data set. You run your integration test. You have certain expectation, and you code that expectation. If the requirement change, the integration starts just failing, then either you have a bug in the code, or you need to change the test, right? But again, setting up integration tests, a bit more complex than unit tests, but also very, very important. And here, set 2 hours, right? Like, so usually, so in our case, we run it at night, right? Or we run it twice a day because we have global development. So we want to make sure that, by the time our team in Wrocław, Poland, finishes, that we can run a full integration of a suite of integration tests. And for example, then somebody else will pick up and know they're starting from a clean slate. Test non-functional requirements, right? How often do we do it? How often do we really go in and say, can our system handle that many transactions? Can our system handle that many requests, right? There are tools available for that, right? Like depending on the setup, depending on how, what kind of requirements you have, there are ways to do it. It's not difficult to do, but like really, how often do we do it, right? And then we have a case where something unusual happened and the system just breaks down, right? So we really need to do it. Again, it should be, this is fairly flexible because it depends on the system, but I'd say between 1 day and 1 week, you should be able to reliably put a system under stress and know what's going on, right? All this takes time, but as you will see, not everything will require a lot of effort and a lot of coding for this, right? Another interesting category, right? Become a productive or new team, right? Like, so I don't know how many of you, like, again, going by the rates, I mean, in Poland, I think it's about, attrition rate's about 20% on average, right? So every fifth one of you actually switched jobs recently, right? So you're setting up a new team, right? And if it takes weeks or months to get familiar with the code, you're not gonna be productive, right? And it's gonna affect the system. Also, there's a direct correlation between how quickly you can become effective versus how quickly and comfortably you can add features to the system. Because whatever your new employee is, they will expect they give you 2 weeks, 3 weeks to get comfortable, and then expectation is start delivering value. So this is important, right? Again, low effective teams, low effectiveness is about 2 months, right? Where Depending on the company, depending on the size of the project, 4 weeks is usually, like you said, like the developer's full project, he comfortable. And how do you know? How, for example, I know that a developer is comfortable with the code base? They're going to start asking questions. Not telling or saying that we need to write the whole thing, but talking to the business, saying that, hey, we can do this, or telling me like, hey, we have this feature, we can do it this way, right? So that's when you know folks are comfortable. Answering business questions, right? Key thing, right? Somebody comes from a different domain, telecom, some other thing, and we're in finance, right? It's all about data. It's all about attributes. It's really name-value pairs. That's what we deal with, right? In different domains, right? But it's ability to answer a basic business question, right? Like, what happened with this corporate action? For example, again, I'm just making a technical, it's a message that came in. Can we track that message? Can we answer, yes, it arrived in our system at 3 p.m. And we processed it within 5 seconds, and it was available, right? So we need to be able to answer these questions coming from the business, and it should take no more than half an hour to be able to trace this type of functionality, right? Launch a new service in production, 3 days, right? This that I was looking at is like, whoo, that one is tough, right? Like, because you have different requirements, different clouds, different providers. So this one is tricky. But if you have it templatized, if it's not, usually it's not a rocket science, right? We duplicating what somebody else done. There are templates, there is shared code, there's other things. It should be possible to do it in 3 days. This is the area where we are still kind of trying to get to that level. But for us, we're not very efficient at that point, where I would say it takes probably up to a month to actually get everything for the first time. And then, as I said, it's up to you how quickly you release and how quickly your business is comfortable with you releasing, right? And finally, validated change was useful to the customer, right? Like, okay, you deploy something, and there's, let's say, a report they run once a month, and you put something that the data is only right, and it's only right on the 31st, and you deployed, first of all, if you deployed on the 30th, then there's a sign of trouble. But let's say you deploy a week earlier just to make sure everything is fine, and you can validate for another week, and 31st come, and something doesn't work, trouble, right? So here, you should be able to determine ability to run the data maybe earlier, but sometimes, you might have to wait a little bit to be able to validate these type of changes, all right? So let's move on. And again, I don't have a lot of slides, guys, so sorry you have to survive through this slide because, remember, my first note, I'm a developer, I don't create the slides. So this was actually, I created the basic, and then our marketing team helped me put the nice graphics, so it wasn't all my work, right? So, best practices. Keep all the links handy, right? Like, as a developer, yeah, we give support to other folks, or maybe there's somebody else that handles it, but you want to be able to answer any kind of question quickly, right? Like, the quicker you do it, the better it is for everybody. So finding the links, finding the information about the project, maybe somebody will ask you to help another team investigate the problem. Finding where things are is very important, so save your link, make sure you're handy, don't just do it when the time comes, right? It's really important to keep a nice, clean list of tools and access, most importantly, right? Because things change all the time, and we want to make sure that that we have access to the monitoring tools, and we don't only check it when there's a fire happening. Learn your tool set. Again, I don't think we do that enough. I don't think we spend enough learning to begin with as developers, right? We learn something, we become good at it, and a lot of times we just don't learn, right? That's another thing that we need to change. We need to change not only the coding. There's so much going on with Java, right? Like, you have to do things change with ecosystem, with the build tools and things. So there's plenty of things to keep things interesting, but we have to know the IDE, right? We should know the IDE, should have to work effectively, because that's what we do, right? So there are other tools as well that you have, whatever it is, learn about it, learn the shortcuts, learn how to operate, right? It's going to help you become a better developer because you can focus more on the coding and not on the tool itself, right? And if you find yourself repeating something 3, 4, 5 times a day, maybe there's a shortcut, maybe there's a better way to do it, right? Keep it clean. Again, that's a logo that could be anywhere, right? Keeping things, it's not difficult. It's very difficult. We have to keep technical debt in check, and throughout the life cycle of the project, right? Monitoring and alerting, right? So always check, and I had an interesting case at my house, right? I had a smoke detector installed in 3 different floors, Nest. Again, somebody mentioned Nest before. And I'm happy, I'm safe, no alerts. And then one of these smoke detectors actually went off. I was like, okay, let me take a look, right? I don't see it on the app. I fixed it, and I'm looking at it, it's like only one smoke detector is visible. And it turned out that the other smoke detector in another floor was offline for 2 years. There was no alert, so I thought, like, I'm happy, right? But like, then I realized for 2 years, like, if something happened, like, it would be a disaster. But like, not having alerts doesn't mean that the production of everything is fine. So there's a big difference. But you have to know that something is not working, or you're not getting the right probes, you're not getting the right signals, in order to feel safe, or like to manage it effectively. It's very important that once in a while check, okay, are all my alerting and monitoring that I had I thought I had is actually there, right? So it's very important. Minimize feedback loops. Again, depending on your setup, agile, sprint, duration, how you do it, it's important to get feedback as soon as possible and deal with it, right? So that's that. Are we doing on time? We have 13 minutes, okay. So typical application setup, right? You have microservices, you have some kind of a router, you have different clusters, maybe set up depending on what you use, right? And this is, again, you might have service deployed across 2 different data centers. Let's say service A, as you can see. You might have service B, again, because they changed it. It used to be in 2 clusters, now they're in 1. But you have another service, C, that's also in 2 clusters, but B is using the cache. Cache is replicated across 2 clusters. So this is the problem with cloud. Beautiful, right? You can develop the service separately, you can deploy them separately in theory, but you have to deal with all these things. And at any point in time, any one of these links could go down, right? Something could be broken. Network goes out, data centers, ports, firewall, somebody changed something, right? So again, there are tools that help you monitor, but the interaction between the services, usually the tools, because it's so specific, there are very few tools that actually allow you to do a good job about this. So you have to put something there yourself to be able to handle these type of cases, right? You don't have connectivity to the database. What happened? Maybe they introducing a patch. So things can break. So when you're looking at it, right, like you can sit down when you have a moment, grab coffee, print something like this, or draw it on the board. Now it's possible. Now we can actually hang out and actually draw stuff on the board, and just discuss among yourself. Okay, what if this goes down? Does it really go down, right? Usually it doesn't happen. Like, although data center in theory can go down, in theory it does. Things like that happen, like some major disaster happen, but it doesn't happen that often, right? So is it worth dealing with that type of scenario where the entire data center goes down, right? You can, it all depends, but like you have to at least have a conversation about it. See what you can do. You have anything to prevent or get alerted when something like that happens, and how your application will react to that. Right, so now is the tricky part. Now I'm going to switch to code. Woo! And this is going to get interesting, right? So luckily 10 minutes, so it's going to be, if anything, it's going to be 10 minutes of shame. So first, like just a basic app. I'm not going to go through a lot of coding, but I just want to show you, if you're not familiar with JHipster, pretty cool app. It's open source, right? And what these guys do, they actually allow you to create application or skeleton of applications, and this is where we spend most time, right? Through like a wizard where they ask you a bunch of questions in the projects, right? Right, and we're gonna do some directory test, and we're gonna go and gonna use JHipster. Ooh, I'm not sure. Oh, and I wish I knew how I can. Oh, hold on, let me check. Oh, And that's the first disaster. I didn't even start doing anything. And we see let's see if I can do the screen. First success. And no, not success because I don't see anything on the screen. That's nice. All right, give me 1 second. I can do duplicate, right? There we go. Beautiful, we're back in business. And it only took 20 seconds. All right, so JHipster, right? JHipster, so the site you can go in and look at it. And I use it like from time to time, just go in, JHipster, right? NPM library, hipster. And what you will do, for those folks that, you should be familiar with that, but if not, it's a, they have a set of wizards, set of questions that you set up like a basic microservice with some UI, with Angular. You can pick a framework, React, Vue, or Angular. But what's interesting about it is that they will set up, and the folks that actually do this, that create this template code, they will actually try to do the best service, best recommendations to set up certain services, right? Like, so for example, I'm going to open a POM file, right, for this, the Spring Boot. So for example, the latest version works with Spring Boot 2.66, right? Like this is the one they recommended. We probably, if you guys work with Java, if you work with Spring, you know about this whole thing with Log4j and the Spring Shell. So that was another interesting event again. So they work with 2.66, but they have certain plugins and they register, they set them up specific way, and it's a open source collaboration project. So a lot of folks contribute to say and have different opinions. So for example, like this is an interest library. If you're not using it, maybe worth taking a look, right? Like what is that? Where are the arc units, architecture units that you can set up to prevent folks adding new packages that previously maybe weren't discussed, so that they actually use it and they think it's worth adding into this type of template project, right? So here you can set up a monolith application, which is just a self-contained service with UI and backend. You can do a microservice. So let's say we do monolith, we do Devoxx, PL. Right. So again, this is I'm not going to go through the whole setup, right? Like, but what I want to show you is something that they created, right? They created a basic application. So take a look at that, right? A lot of cool stuff, a lot of things that's being done. But they created this basic application for me, and I'm going to start this, right? So this is a basic Spring Boot service, and what you will notice here, like. First, what I want to do, okay, let's pretend this service is running in the cloud, right? It wouldn't take a long time to deploy it on the cloud because it's a self-contained jar. Now, it's all of a sudden, I want to know what's the first thing, let's say something is wrong with it. Like you have to ask yourself, like, what kind of question would I ask 2 in the morning? Like, and so there are some basic things that you can do, and unfortunately, JHipster doesn't add it by default, so I had to add it manually. I'm going to show you how I added it. But like, for me, the first thing that I want to know, what's the latest version of this service? Right? It's a jar. It came from Nexus. It came from somewhere. But I want to know what it is, right? So here, Spring Boot provides this functionality actuators, right, like production actuators. So there are some that come by default. Like, for example, you go to a predefined point, and actually JHipster decided that it's a good practice to change actuator link to management. Okay, I can see it, why they did it, why they think it's a good practice, right? And then you either go to help or to info, right? So I'm going to go to info first. Let me go to info, right? And in the info, the first thing that I get, and again, I had to tweak certain plugins on the JHipster generator, or add my own, to show that, for example, and now this is not showing, like in the Git, like in the build section, right? I'm seeing that this artifact was built. When was it built? It was built, it was built this morning, right? So that's where the build. Now, another one that I'm actually looking at is, okay, when did it start? When did the serve start? And again, you can get it from logs. You probably have Kibana or something else to capture the logs, but it takes time to get it. I want to go somewhere and find out that, yes, this started 10 minutes ago. Maybe the service was bounced. Maybe it keeps bouncing every 5 minutes. You don't even know. So it's very important to know that it was started, right? So that's one of the rest points. The other one that's very important, like I have to run another Maven command, show you a Git information. Like if it's somewhere in Git, if it has to be in Git, what's the commit, last commit that this package was built with? Super important, right? I can go in, grab the commit ID, look in my source repository and say, okay, what was changed? And so you have it in the Git section. You can enable it. It's by default is disabled, so I'll show you guys later if you stop by the booth how to do it. That's our secret. But there's another one, like for example, Spring Boot provides. So, for example, health, right? They also do this. Health. All right. So by default, let's say Spring Boot comes with database. If you have a database driver, if you have a data source definition in your project, they will give you a kind of the health check to verify that your database is up. Maybe every 5 seconds, you can control all of that. 5, 10 seconds, they will run a query. Hello, select one from Duo or something, whatever it is, to know that the link between the database is up, right? Whatever components you do, you can have the health checked. Now, if you have your custom components, it's very easy also to add your own health, right? And here, for example, disk space. How many, again, on the cloud is not that relevant, but let's say you're running on some container that has limited disk space, run out of disk space, and some weird things start happening, right? So it might be worth having something like this, right? So there are different, and you can develop your health check as well. Now, all frameworks out there, like most of the frameworks that I know, like they have some functionality like this similar because it's essential to have it in production. But again, I'm referring to Spring Boot because it's very easy to have something like this, right? So I'm going to show you an example. I can't connect to GitHub, to my repository, right? That's fine. That a custom startup info, right? It's not available there with the sample application, but how easy it is to have to add this, for example, this info point that has started into this info place, right? It's just a couple of lines of code, and here I can see this. Now, somebody could say, yes, this code could be better, you shouldn't have a string, hard-coded in your method, it should be a constant. All this, great. Yeah, we can optimize, we can work with it, we can add a test. There's definitely a test for this class. I could not force myself to add code without test, but like we can do the green, red refactor. We can refactor this code. But the fact that we have something that I know that it started 5 minutes ago, 2 hours ago, or let's say Saturday when the deployment happened, it's really helpful, right? So easy, look for these type of things. No matter what framework you use, I'm not recommending, I'm not telling you guys that Spring Boot is, I think it's right now that's what kind of we use in finance, seem to be the most widely accepted, but there are others, right? But look for these type of things, how easy is to not only write the code, but how easy is to add these type of features that will help you with production support, right? So it's very important that you guys do this, right? Again, this is, if anybody's interested, the link to the GitHub will be available, the presentation will be available so you can look at it, but you can just go to Springside and they have plenty of examples how to do this. Right, so health info, writing custom information, context is important. It's very important to have these things. Now, I have 1 minute, so I'm going to, guys, now make you read all this, and by the entrance, we'll have the guys sign non-disclosure. No, I'm just kidding, right? So this is our guys. We had to put this in, so when you read it, don't read it. You don't have to read it, right? I'll be outside. I'll be outside in the booth. We have a Bank of New York Mellon booth. Again, we're a bank for banks, but we're a big technology house. We're driving finance through technology, looking for good developers. that want to solve problems and the things in the domain that always changes, right? So always, every week, there's something always interesting happening. So thank you very much for this, for your time. Unfortunately, I can't ask you questions because it's very hard for me to deal with it. But I'll be in the booth outside. Stop by, let's chat, let's use this opportunity to be together, to ask each other questions, and have a good rest of the conference. Thank you.